All right, welcome back. This is going to be part 3 for the Unit 2 lecture for the Living World Biodiversity. Again, you're going to want to be taking notes during this. As you get some of these, feel free to pause as you need to. So in this video, we're specifically going to look at island biogeography, ecological tolerance, and natural disruptions to ecosystems. So we'll start with island biogeography. Island biogeography is the study of relationships and distribution of organisms on islands. So specifically, we're looking at the biology and the geography of islands, because islands and where they're located, how large they are, how far away they are from mainland, this all impacts the ability for different species to get there. They have been colonized in the past by new species arriving from elsewhere. Islands didn't, have a species start there. All species had to get there. Most of these species have evolved to be specialists rather than generalists because there are so few resources available, and there's a small amount of territory. And we remember back from the first video that specialist survivals is threatened by very, very little things. So any habitat disruption is going to harm specialists' ability to survive. Typically, as an invasive species is introduced, like a generalist, most invasive species are generalists. This is where you get harm to those species that are on these islands. And we'll do an activity in class where we'll simulate island biogeography to be able to see kind of how this is impacted, and how it's a pretty simple concept, but something that hopefully will make sense. So you can kind of get an idea. This is based on the closeness to the mainland, or how far it is from the mainland, and then small islands and large islands, and you can get an idea of how rich the species population is. So you can see here that large islands are going to have more richness if they are closer to the mainland. So many species on a large nearby island, where there are few species on a small distant island. So where these cross is what's important here. So we'll look at that specifically, but the blue lines are the probability or the rate of colonization. So the closer you are to the mainland, you can see on the blue, the closer you are to the mainland, the more species richness you're going to have. The farther you are, the less you're going to have. So we'll also look at ecological tolerance. Remember, we talked about niches or niches, depending on how you like to say it. This is just different conditions. Typically, these are things that we measure when we go out in the field. So when we go on our Whites Creek field trip, we're measuring different properties of the water, and we're looking at a lot of these conditions. So we're going to look at temperature and salinity and flow rate, but also sunlight. These are specifically how wide of a range these different species could endure before they are either injured or die and are unable to reproduce. And this can apply to individuals or to species. This is where those genetic differences come into place. This is where genetic biodiversity is important, because different genes allow for different tolerances. So the law of tolerance, this is kind of what a niche or niche looks like. For every abiotic factor, an organism has a range of tolerance that it can survive. Obviously, the preferred range is going to be that middle big green here. This is the preferred range, right? This would be too high, too low, way too low. So some examples would be pH. So too acidic on this end. So you can imagine that this is where species will completely avoid or die if the pH or even if the temperature is too cold. And then there's some amount of, they can survive in here, but there is going to be some physiological stress. And then on the other side, you get the exact same thing when these things go too high. So you can think of any type of abiotic factor that exists. There's going to be a range of tolerance for a species with those abiotic factors. And obviously there are many natural disruptions that occur to ecosystems, which all can harm the tolerances for those species. These can be huge disruptions, but they can also be smaller disruptions. So one of the most important things to get here is that there are natural disruptions that occur that can be as great as or even greater than human-made disruptions. For instance, an asteroid hitting the Earth, that is a natural disruption. It's not happening because of humans. We're not shooting asteroids at the Earth yet. Let's not assume that we won't at some day. But these are natural things that occur, and they can cause many disturbances and cause a lot of species to die. But it is natural. So when we look at different changes that occur on Earth, we look at different timescales. So the different types of Earth's timescales are periodic, episodic, and random. So periodic occurs on a regular cycle. Every 1,000 years this thing happens. Episodic occurs and continues to occur, but it's fairly random. It repeats, but there's not a specific period to it. And then random timescales are just there's no pattern. There's an unknown pattern that it happens, and it might happen again or it might not. We don't know. So what's really important to look at is climate over geological time. So you can get an idea here. These are two graphs looking at the temperature of the Earth, the natural temperature of the Earth, and how it changes. So you can see that this is a periodic type of thing. We have rises and falls and rises and falls and rises and falls and rises and falls, and it's fairly periodic. You can kind of get an idea that every certain number of years this is going to happen. What we do see in the Pliocene and the Pleistocene is that temperature has been gradually falling. So since the last ice age, temperatures began to rise. On a smaller scale, if we're looking specifically at, or on a larger scale overall, you might not see the overall picture. So this, obviously, you can see is just years before present. So we're looking at 0.1 million to 0.2 million, so 300,000, 400,000, all the way up. And all of this bottom graph occurs right in this area here, okay? And this is a longer scale. So we're looking back 5.5 million years. You can see that there's been a gradual lowering of the temperature. And right now, as we are starting to get in, we see that we're entering this larger rise, which many people would say, hey, look, we're about due, aren't we? The problem is, and we'll see it when we look into global warming and climate change and human-caused climate change, is that it is happening at a faster rate than ever before, and that's what kind of gets people nervous about this. It's also important to understand that sea levels have also changed over geological time. Okay, it's based on the amount of glacial ice on Earth. If you have a lot of ice, sea levels are going to be lower. As the ice melts, sea levels are going to rise. It's kind of obvious, but they have varied significantly based on some of these scales of Earth's time scales that we've looked at. So you get an idea here, just looking at hundreds of millions of years. The level of sea level has changed quite a lot, but we are seeing a rise currently, which we had started, at the end of the Cretaceous period, and this is kind of a natural thing. Another problem, though, is when we go back as far as 250 or almost 260 million years ago, those sea levels were pretty high, and we are looking now at this graph starting to look like it's going to go up, and that's what kind of gets scary. But you can see here in the middle of the Cretaceous period, at the lowest point, we're looking at, these are in meters, where the natural sea level was almost 400 meters below what it is today. And this obviously is shown with many of the fossils that we found, which kind of help us understand, hey, the ichthyosaur, for instance, which was found in Great Basin, was a very large fish. And I don't know if you guys know this, but Nevada's not the ocean, but as plate tectonics move our different continents and sea levels change, we get different species, and this is that's the evidence that we have to show that this is obviously something that's happened. So that's going to be the end of part 3. We're going to do part 4 next, so make sure you check out part 4 when you're done and when you have some time.